Yeah, comes on everyone. Let's start off. The last thing we did, we are discussing about this translational and rotational motion. Are the scams on? So again, like I said, we defined translation and rotation, right, for bodies. Whereas you define circular motion for particles. So, for example, if I had to give you one more example, let's say if you have a car, right, and it is going on a circle like this. Now, if you look at these points here, A, B, C, D. So as the car goes here, you can see A is going in a smaller circle. D is going in a bigger circle. So here, if you say body goes in a rotational motion, and A, B, C, D are in circular motion. Where are the rest? Right? Why so many people are absent? Didn't I send the link? Yeah. Oh God. If I don't send the link, people won't join. My mistake. Seriously, you guys didn't realize for the last 3-4 months that it is the same link I sent every time. Chalo, cams on. Let's start off. Chalo, let's go ahead. So there's the last class we were doing the translation rotational motion. Now, if you see, right, everything, all bodies, right, will not be every time in pure translation or pure rotation. You will see combinations also. For example, if you take a rolling wheel, if you take your car ka vehicle, car ka tire or something, you will notice this. The wheel is also going forward and the wheel is also rotating. Other scans on. And I was wondering why no one joined because I didn't send the link. Anyways, it is the same link from last 3 months. So do notice it. Anyways, my mistake. Next thing. So if you see here, right? So when you have a rolling wheel, now I cannot study this directly. Getting it? It becomes very complex. But if I split the motion into a translation, means the wheel is simply going forward and the wheel is simply rotating with omega. I can split the motion into 2 parts. It suddenly becomes easy to do. This is a rotational motion about center of mass, or in this case, about center. So a rolling wheel is a combination of translation plus rotation. If you think about Earth, about the sun, think about it. Around the sun, Earth is going in a circle, and Earth itself is rotating. It is a combination of rotation plus rotation. Another example, right? If you see in the house, if you look at your table fan, so if you have a swinging table fan, you must have noticed this. When a table fan is put on a swing mode, there are actually two rotations. The fan itself is rotating, and this whole fan is rotating in another direction. So if you can split this motion into two parts, again, you will notice we will handle these kind of questions in rotational mechanics. So this is one rotation. Plus the center of the fan itself is going in another rotation. So every motion, right, can be simplified into a combination of translation plus rotation, translation, rotation plus rotation. Getting it? If you ever been to Imagicana, there is a ride called Cup and Saucer ride. Did you get into that? If you see that ride now, you have a big disc, right, which is rotating. In that, you're sitting in a cup, and the cup itself is rotating. So, and both are rotating with different omegas. So when you're sitting in this cup now, in this position, both the omegas add up, you go fast. In this position, both the omegas will subtract, you go slow. So you will find some places you're going fast, some places you're going slow. If you've been in that cup and saucer ride, that is also a double rotation. Clear with this? So like I said, this chapter is a bridge, between whatever we have studied so far is all translation. We have treated the whole body to be a particle. Next chapter that we're going to see, rotation will be something else. So this is a bridge between them. So we will see rolling motion, we will see all this kind of stuff. So what is the center of mass exactly? So center of mass is again, people have observed it is not, yeah, you can locate it, but technically speaking, it is just a concept. Consider a body projected into the air. So we observe a certain point moves in a parabolic path. Basically, the projectile motion. So till now, what we did, when you're throwing particles into the air, you always treated that body as a point object. Matlab, if I say I'm throwing a rod into the air, we actually never cared about the rotation of the rod. We always took the simply, that I treat it as a particle. But in reality, there'll be only one point which will actually go in a projectile parabola, and the remaining points are going in a circle about it. Let me show you how it looks. And remaining points rotate this point. This point is called center of mass. There's a bit of a theory, and this will be the first chapter, where we'll be using extensively calculus, on how to choose elements and how to integrate and all. This will be the first time you will be encountering. And whatever integrations I'll teach you here, the same integrations will repeat in rotation, gravitation, electrostatics, magnetism, right? Any chapter, the integration elements will look same. So this will be the foundation chapter for that. So if I take a rod, right, and let's say if I throw this into the air, if I take a uniform rod, you will observe the center of the rod actually goes in a projectile motion. And if you look at the rest of the point particles, let's say this is A and this is B, and let's say this thing is also spinning. Let's say someone gave it some rotation. So you have thrown the rod with some rotation. You will notice the rod becomes like this. Then the rod becomes like this. Basically, this is A. This is A. So if you observe this motion of A, right, A and B are going in circles about the center. And this is how the motion will be. So if I actually ask you how is A going, this will be the path of A. It's like some jalebi types. Can you see how the path of it's pretty complex? But if I ask you to study A, right, all you need to do is find the position of the center, and from the center find the position of A. So this is actually a combination of a parabola plus a circular motion. Are you getting clear with this thing? So you will always notice this. Whenever you throw particles into there, you'll always find a particle. So here C is the center of mass. We will see later on how to look at that center of mass. So whenever you're throwing objects into the air, only the center of mass will behave like a projectile. So till now we have studied that only. Whenever I said find the range of the rod, you didn't find the range of point A, you found the range of point C. When I said find H max of the rod, tell me one thing. If I say H max of the rod, isn't A at a higher height? Clear? Every point on the rod is going to different heights. So when I say H max of the rod, which point are you exactly talking about? So this is what we did so far. We ignored the size of the rod and you treated the whole thing as a particle. So which particle did you take then? We took the center of mass. In this case, the center of the rod. So that was the thing. And so far in all the chapters we did, we treated everything like a particle. And that particle was always at the center of mass. This is how it would look. So they're taking some objects and they're throwing into the air. Can you see how is that rotating and going? They took a ball and this thing is again rotating and falling. I'll post this video in the group anyway. That's the best. You can just see that thing. First thing, he took some tennis bat kind of thing and is throwing into the air. You can see it is rotating. There you can see it. Can you see how it is rotating? I'm pausing it. Right? If you see every point is going in different motion. Now what they did, they painted the center of mass with an orange paint and they switched off the lights. Now if you see now in the screen, can you see that orange spot which is glowing? So that is actually the tennis bat which he threw in the beginning. He's throwing it again, but this time you can see only the orange spot which is the center of mass. Now look at that orange spot, how it goes. Did you notice that? When he threw it, see, it just behaves like a particle. You can clearly see it is going in a projectile motion, parabola. So when you're throwing anything into the air, the parabolic motion is only, done by the center of mass, and everyone else is just going in some weird paths. This is the disk. Again, you will see basically all parabolas there. Clear with that? So you'll always find a hypothetical point called center of mass. No matter what kind of system you take, you'll find a point. When you throw that, it'll always go in a projectile motion, and everything else is going in a circle. Let's see a question based on this concept. Let's say we got a rod. This is the center, which is origin 0, 0. Let's say this is point A, which is L by 2, 0. This is point B, which is minus L by 2, 0. The center is projected with you at an angle theta. And this whole rod is also given angular velocity omega, like this. So after some time, you will observe the rod becomes like this. Gravity is there. A rod is thrown with speed u at angle theta with angular velocity omega as shown. Find the coordinates of point A at time t. If I know the coordinates of A, I'll get everything. I can find speed and everything. Find coordinates of point A at time t. Here, the center of the rod is the center of mass. If it's a uniform rod, it will be the center. Later on, we will see if the rods are not uniform, it need not be in the center. Let's see how you handle this. There, I just taught you one simple concept. Whenever you throw something into the air, the center of mass will go in a parabola and everything else will go in a circle. It is basically a combination of a projectile motion plus circular motion. I didn't teach you anything more than that for center of mass. So using this information, find the coordinates of point A at time t. Hope the question was clear. Anyone not clear with the picture, please ask me. Shreyansh, your cam is blank, right? Can't see you. See if you can do something about it. Think. Take 2 minutes, think about it, then I'll tell you something. Give me both the coordinates, na, Srihari? Yeah, x coordinate is right though. How do we start? See, forget about point A. First, find the coordinates of the center. Start from there. Then stand on the center and look at point A. It will be going in a circle. Then find the coordinates of A with respect to center. Then just add them up. Split the motion into two parts. Right, sure. You get the y coordinate. Right, Srihari. Hmm. And did you guys include that A is already, it doesn't matter actually. So yeah, I think yeah, most of you got it right, Srihari. Right, Sudesh, Samyak. Let's see. So when you're throwing this, this guy is going in some projectile motion. This is your origin. So this is the center. Let's call it C. So C ka coordinates will be the x coordinate of C will be u cos theta t. Y coordinate of C will be u sin theta t minus half gt squared. Standard kinematics ka equations. In case you forgot, you should definitely go back and revise kinematics once for projectile motion. Now here, let this angle be theta. Now you can ask me, sir, how do I know theta is like this and not like this? Don't worry, theta, the sign will take care of it. Theta is nothing but omega into t. So if the time is more, omega will become obtuse automatically. The signs will take care of themselves. This is point A. So from here, if you drop the perpendicular, this will be L by 2 because this is half of the rod. That will be L by 2 sine theta, and this will be L by 2 cos theta. That means from point C, you have to travel L by 2 cos theta forward. So that will be u cos theta t, x coordinate of C, plus L by, wait, let me write it as alpha because I'm already using theta for this. Because initial theta is already given now. That will be confusing. L by 2 sine alpha, which is u cos theta 2 plus L by 2 sine omega t. Similarly, y coordinate of A will be y coordinate of C, which is u sine theta t minus r g t square, and then it is at a height of L by this is cos alpha. This will be L by 2 sine omega t. Clear with this? So depending on the time, that sine function can be positive or negative. The signs will take care of it. You need not worry about it. So always, whenever you're solving with variables, preferably keep it acute angles only. Don't mess it up. Keep it acute angle, solve, the signs will take care. Easy? So if you see in terms of a projectile motion plus circular motion, it becomes easy to handle. But if you actually ask you to draw the path of A, it would be pretty messed up. Clear with this? Can you find the acceleration of point A? If I ask you this, find the acceleration of point A. What will you do for that? Omega is constant. Think, take a minute. They can ask you a question something like, find the maximum acceleration of point A or find the minimum acceleration of point A. or acceleration of A at time t. Hmm. See, again, same story. This thing has actually two accelerations. If you observe your C itself, so if you stand at point C and if you look at point A, you know A is going in a circle. So this point C will think A is going in a circle. No one else will think A is going in a circle. So we'll have a centripetal acceleration AC, which is omega square L by 2 towards the center. This is the acceleration of point A with respect to the center. This is acceleration of A with respect to the center. So which is actually changing every instant. Getting it? So, and if I take this angle to be theta, which will turn out to be omega square L by 2 minus cos theta I cap minus sine theta j cap. So acceleration of point A with respect to the ground will be acceleration of point A with respect to the center, because only the center thinks you're going in a circle, and acceleration of the center with respect to the ground, and center of the rod is falling with gravity g. So this will be omega square L by 2 minus cos theta I cap minus sine theta j cap. Again, remember I'm taking theta to be acute. If theta is not acute, science will take care of it. Why am I taking theta every time? Alpha. And acceleration of the center will be minus g j cap. That's your answer, everyone. What is the maximum acceleration when both are in the same direction? Minimum acceleration, both are in the opposite direction. Clear with this? So acceleration of point is not constant, it is changing every instant. So it has two components of acceleration. All clear with this? Yeah, you can play around like this. If something is going in translation and circular motion, you can use everything that you learned before, it will work. That is one thing. So how do we locate the center of mass? So this chapter, right, actually has four parts. First thing is your center of mass. Second thing is your momentum. Third is collisions. Fourth is variable mass system. A decent chapter. So if you have different particles, M1, M2, so on till Mn, let's say R1 bar, R2 bar, and Rn bar. The position vector. So here basically what is R bar? R bar is your position vector, which is xi cap plus yj cap plus zj cap. Zk cap. So the position vector of center of mass is given by M1 R1 bar plus M2 R2 bar, so on. So you have to multiply the mass into the position vector by total mass. Later on we will see how this came also. You can simply write this thing as sigma mi ri, where I goes from 1 to n, by sigma mi. If you actually put a differential on both the sides, delta, so delta r COM, that is the change in position of center of mass, will be sigma mi, change in position of each particle, because m is anyway constant, so the differential part will just go inside. This is quite a useful thing. We are going to use this later on. So whenever you want to find center of mass, like it's say instead of your it's in mathematics now, this is also called as weighted average. So here m is the mass of the particle. So in this, if you just want the x coordinate, then you just take the x coordinates. X coordinate of center of mass will be sigma mi xi by sigma mi. If you want y center of mass, then we use sigma mi yi by sigma mi. Z coordinate will be sigma mi zi by sigma mi. Right? This we use it for particles. So if you give me particles like 10, 15 particles and you want center of mass, we use this for particles. But sometimes we have to deal with continuous bodies. What are continuous bodies? Maybe a sphere, disk, plates. These are continuous bodies. Then your formula becomes, let me write in the next page. So when particles are given, use this formula, sigma mi ri and everything. You can put it down in case you want. Easy to remember though. And others do keep your cams on. Now if you're dealing with continuous bodies, continuous bodies meaning sphere, disk, plates, etc. Then your formula x center of mass becomes integral x dm by integral dm. If you think about it, it is the same formula. See, integral x center of mass is sigma, summation is integral mi xi by sigma mi. This is the same thing for particles. So here, what is this x coordinate? This x coordinate here, I'll show you how to use this later on. So this is the x coordinate. So whenever you have a continuous body, you divide the whole thing into small pieces. That x is the, sigma is integration. So x coordinate of the dm particle. If you remember, that is how I integrated. I showed you the integration also. Sigma becomes an integral symbol. For y coordinate, it will be integral y dm by integral dm. So when you're dealing with continuous bodies, use integral. When you're dealing with particles, use that sigma mi ri thing. Technically, both are the same formula. It just depends on what shape you're dealing with. Clear with this? Let's start off with a question. Any doubt so far? This is x, y, z. This is a cube of side A. We have a particle here, m, which is a midpoint of this side. We have a particle here, 2m. We have a particle here, 3m. This is the face center. And we have one particle here, 4m. That is also the midpoint of the side. Find the center mass of this system. I taught you how to find the coordinates of a cube, remember? You know which chapter? Vectors. Find AD bar, AB bar, BC bar. You learned how to find coordinates here. Let's get this. So there are four particles, M, 2M, 3M, 4M. M and 4M are the midpoints of the sides. 2M is in the corner. 3M is the face center. There are six faces of a cube. It is the center of that face. Easy one. Just get the coordinates and put it in the formula. There's nothing to think. Try. Yeah, give it 2 minutes. Is brute force working? Let's get the coordinates. 'How did you get M in the coordinates, Ray God? Hmm, 7 by 10. Let's see when I don't know the answer for this. 7, 8, 9. Yeah, we have different answers. 0.78, 0.45. Let's see. Let's get the coordinates first, everyone. If you got the coordinates, question is over. There's nothing there. I told you how to get the coordinates. So it's like you're traveling from the origin. If you go along the z-axis, only the z coordinate will change. So this coordinate will be 0, 0, a. And from here, when you go up in the y-axis, only the y coordinate will change. So this coordinate is 0, a by 2, a. This 2m ka coordinate will be a, a. To reach 3m, I will go straight till here. This is a, 0, 0. Then I'll go till this midpoint here. That will be a, a by 2. And then I'll go this side in the z-axis. So this is actually a, a by 2, a by 2. And for 4m, I'll go straight up in the y direction. And then I'll go in the x direction a by 2. So this guy is a by 2, a, 0. Check your coordinates. X center of mass will be mass into the x coordinate. This guy will be m into 0 plus 2m into a plus 3m into a 4m into a by 2. And the total mass is 10m. That would be 2 plus 3, 5 plus 2, 7, 7 by 10a. Y center of mass will be ma by 2. 2 MA, 3 MA by 2, 4 MA by 10 M. How much is this? 3 by 2 plus this 2, 2, 4, 4, 8. 8 by 10 A or 4 by 5? This will be 3 plus 3 by 2, 3 plus 2, 6, 6 plus 3, 9, 9 by 20. Check your answers. Clear? Nothing there, just need to get the coordinates, put it there. There's nothing to think in this. Any doubts on this? Next thing. Let's say you have a square. This is an easy one, but I just want to show you something here, make a statement. This is M, this is 2M, this is 3M, this is 4M. Let's call this thing particle A, particle B, particle C, and particle D. First thing, find center of mass of A and B. So take A and B as a system, find the center of mass, then find the center of mass of C and D separately, and then find the center of mass of AB and CD. Meaning you took AB as a center of mass, so you'll get one center of mass, you'll get CD as a center of mass, you'll get one center of mass. I want the center of mass of these two center of masses.
So can you repeat the question?
We have 4 particles here. So find the center of mass first A and B, find the center of mass of C and D. So you'll get 2 center of masses. Right?
Yes,
Now find the center of mass of these 2 center of masses. So treat AB as one particle, treat CD as one particle, and try to find the center of mass of these 2 particles. And we will prove that will be the center of mass of all the 4 particles, which kind of makes sense, but it's a very important statement. Let's just get this thing. I hope everyone is clear what I'm trying to ask you. AB is one system, CD is one system. You'll get 2 center of masses. So these 2 center of masses will be like 2 different particles. Then these 2 particles ka center of mass. So center of mass of center of masses. Yeah, first one is easy. Yeah, this is an easy one. Let's see. So first, when you find the center of mass for AB, X center of mass will be 2A by 3. Y center of mass will be 0. When you do for CD, X center of mass will be 3a by 7, and y center of mass is a. So now what you're doing, you're going to replace AB ka center of mass. So here somewhere this point, we'll call this AB. So the mass of this thing is 3m. So you're replacing the total mass 3m with this, with the coordinates 2a comma 3y 0. Similarly, you can replace CD with a single point here. Let's call it CD, whose mass is 4m plus 3m, 7m. So that is the thing about this. You can replace the whole mass with a single particle at the center of mass. And now when you try to find the center of mass of these 2 points, we'll get a new center of mass. This will be center of mass of ABCD. And if you try to calculate this, x center of mass, so this is how you do 3m into 2a by 3 plus 7m into 3a by 7 by total mass is 3m plus 7m. And this is a by 2. Similarly, y center of mass will be 3m into 0, 7m into a. So this gives us one very important statement. Clear with this? I know it looks a little simple and silly, but it's a very powerful statement. So what this thing says is, if a system is divided into n parts, this will be actually useful to find center of mass, some systems which are assembled. I'll show you. The system is divided into n parts. The center of mass of the center of mass of this n parts is the center of mass of the system. And it looks like some broken tape recorder statement. The center of mass of the center of mass of the n parts is the center of mass of the system. Meaning, for example, let's say there are a lot of particles. So if you divide all these particles into one system, second system, third system, fourth system, fifth, sixth, seven, and so on. Now each system will have its respective center of mass C1, C2, C3, and Cn. So I can treat each of this as a particle of its own. And if you try to find the center mass of all these things, this will be the center mass of all n particles. Center mass of C1, C2, C3, and so on till Cn. Which kind of looks obvious, but so how is this useful? So later on, we will handle questions of this sort. Let's say example, if I give you a shape like this, a cone and a hemisphere, an inverted ice cream cone basically. And they're going to ask you find the center mass of this system. Now, this is not any regular shape. I don't know how to solve this, but later on we will prove for a cone, we know the center of mass, it will be C1. For a hemisphere, we know the center of mass C2. So we replace that entire cone with a particle. We replace this entire hemisphere with a particle. And then we find the center mass of these two particles. And then we'll make an argument. This will be the center mass of that shape. This is the center of mass of C1 and C2. Will be the center mass of that cone and of the shape. Clear with this? So whenever you create systems with some pieces and you know the center mass of those pieces, you can actually replace them with particles and find the center of mass. Is this making sense? Later on, we're going to do problems, so we get more clarity. But that is the importance of that statement. Any doubt so far? Let's write a few more theoretical points. If you have only a two-particle system, the center of mass is always along the line joining them and between them. That means, let's say you have created some dumbbell like this, where one side of the mass is 2m and where one side is mass m. It's an unequal dumbbell. So you can clearly see the center of mass will be more closer to this guy. Actually, if you try to calculate, you will get this length is L by 3 and this length is 2L by 3. The meaning of this is if you throw this into air, the center of mass will go in a parabolic path. And this weird dumbbell which you have created, you know how it will go? So this 2m will go in a smaller circle. And this m will go in a bigger circle. That is how the motion will be. The idea is still the same. The center of mass will go in a projectile motion and everyone else is going in circles. So if you throw a dumbbell like this, m and 2m into the air, the center of mass will go in a projectile motion. And the other two particles will go in circles about the center. So in this case, there will be an unequal circles. Clear with this? So you can simply think of like that. The center of mass represents the translation motion. So whenever you throw bodies into there with a spin, there is always one particle. That guy is going with a like a regular particle. That's your projectile motion. Next thing, center of mass, right, can also be, since you can replace the whole thing there, is a point about which we can assume all the mass is concentrated. About which we can assume total mass is present. Mathematically, it works out. That is, draw weight vector from center of mass. That means till now in NLM and every chapter, when I say draw an FBD, you always drew mg from the center of mass. For example, when I ask you to draw the FBD, something of this shape, if I ask you to draw the FBD of this, where will you put mg exactly? Right, so mg will be something somewhere here. So you'll see that. These are few of the properties of center of mass. Then there's one more. You must have heard this word, center of gravity. I think let's write that point last. Next thing, center of mass, right? There need not be mass at the center of mass. And center of mass need not be on the body. For example, if you take a ring, you can see by symmetry, where is the center of mass? In the center. Or if you take a boomerang, you can clearly see center of mass is in the center. There is no mass there. The center of mass is here. It is not on the body also. Like I said, center of mass is a concept which we created for our convenience. And luckily it works mathematically. It is a point about which motion can be split. So this point, there need not be mass there. Sometimes you can't touch the center of mass. For a ring, you can't touch in the center. But when I throw the ring in there, this is the point which will go in a parabola. When I throw this boomerang into there, this point will go in a parabola. So even when you're throwing a boomerang, it's still going in a parabola. Yeah, neglecting air resistance. But the reason why the boomerang comes back is because there is an air resistance and the other things happen. There are external forces. But if you throw a boomerang in a vacuum, it will just go like a projectile motion. It won't come back. So be careful with that. Center of mass is a hypothetical concept which we created. We can always find a point which will behave like a point particle. There need not be any mass at the center of mass. COM always lies on the line of symmetry. If you can find a line of symmetry, the center of mass will lie on it. If there are two lines of symmetry, it will be on the intersection. This will be sometimes useful to approximately figure out at least, partially some values of center of mass. If there are two lines of symmetry, it will be an intersection. For example, if you take an half disk, again, what is line of symmetry? Line of symmetry is when you draw that line, either side of the line will look identical. You can't tell the difference. If you take an half disk and if you draw a line like this, the left and right will look similar. In general, if you see human faces, right, we are supposed to be symmetrical. If you see about the center of the line, your left and right, technically they would look same. Yeah, but yeah, we humans, right? Some people will have one eye bigger, one eye small. Left side is more dark, right side is little shaded, right? So that is what makes us unique. So if you're into modeling, right, you know how they select models? Not based on how beautiful you are. It is based on how symmetrical your face is. So one of the criteria to become a supermodel, right, your face should have some symmetry of 96 or 97%, something of that. So I think 94, I guess. Most of our faces are not that symmetrical. You have a pimple on one side, your symmetry is gone. Right? Your nose is twisted, or maybe there's a small scar, there is a small pimple, there's a small spot or something. So why all that? Look at your hairstyle. At least for boys, so there's no symmetry only. Until unless you make a thing from the middle like this. So, and that is the reason. Did you ever notice when you take a photograph and look at yourself? I think nowadays, right, the phones have that feature. They reverse the left and right. But previously, right, did you ever notice this? When you take a photograph, your photo looks a little weird. Did you ever feel that? Look at the photograph, it will feel little weird. If you take with an old camera, the reason we are used to seeing ourselves in a mirror, isn't it? Whenever you look at yourself, you look in the mirror. In your mirror, left is right and right is left. And when you take a photograph, when you look at yourself, you know it is you, but you'll feel something is missing, something is messed up. Your hair, which is from left to right, will look right to left. So you will find there is some issue with the photograph. But nowadays, if you look at the phones, they have a software. So they adjust the thing also. So if you look at a square plate, there are two lines of symmetry. There are a lot of lines of symmetry. All these are lines of symmetry. So this is the center of mass. Even if you take a boomerang, there is a line of symmetry. Symmetry is quite an important concept.
So
We will also use this to solve circuits. Right?
So what's a boomerang?
Yeah, you don't know seriously what's a boomerang? Movies में they show ना the hero or villain takes and throws and kills the people. नहीं देखा ऐसा कुछ?
So which movie?
Just go and search ना रे Google में boomerang.
Okay, sir.
Never seen a boomerang. You throw and it goes and rotates and comes back.
No, sir.
ठीक है, you are out of this thing then. Check
I've
कर लेना,
heard
you will
of
find.
things like that, but I didn't know it's called boomerang.
It's called boomerang. एक बार search कर लो, you'll find it. These things actually come back to you again. You have to catch it properly though. If you don't catch it, it'll hit you again. So I heard like in Australian hunters, they used to use this for hunting. That is one. Next thing. These are all the properties. Center of mass always lies within the extreme boundaries of the system. Extreme boundary of the system. What is the meaning of that? Let's say if you have n particles, if you just join the extreme particles, right? This is your extreme boundary. The center of mass must lie within this. And mathematically, it makes sense. Since you're taking average M1, R1, M2, R2, it should be somewhere in the inside. The center of mass has to be within that. Again, be careful. Center of mass need not be on the body, but it has to be within the extreme boundary. For example, if you take this boomerang thing, this shape, if you look at this, the center of mass is not on the body. But if you draw the extreme boundary here, that is join the three particles, the three corners, it is within the extreme boundary. If you take triangular plates, center of mass of uniform triangular plates is at the centroid. That means if you take a plate, doesn't matter, scalene triangle, anything, the center of mass is at the centroid. And we don't have the proof for that, but just remember the result. Clear with this? Take a break, come back by 9:47. Any doubt so far? So I'll come back in 5 minutes. So let's start off. What if you have a weird shape, like there's no symmetry, nothing? Then this is how you find a center of mass. If you take a body and if you suspend it by a string, line joining center of mass and the point of suspension is always vertical. This actually comes from rotation. Net torque should be 0 or else it will keep rotating. So that means if you give me some amoeba shape here, and let's say if you tie it to a rope here, this works even for a non-uniform body, it doesn't matter. So if this is your point of suspension, so on this line somewhere, the center must be there. So basically the mg, when it passes through, there'll be no torque. We will see that in rotation. Then if you take the same body there and if you put it in another orientation, it's just this called line AB. I know it's not the same shape, but let's say this was line AB. And now when you suspend this, so again, the center must be somewhere on the green line, so it should be on the point of intersection. So this is how you can find center of mass for irregular shapes. If you take something like this, an L-shaped rod, and if you suspend here, again, same thing you'll notice. If you draw a vertical line, the center must be somewhere here. So whenever you suspend a body, the center mass will be exactly under the point of suspension. If it is not under the point of suspension, the mg will create a torque and the body will rotate. So this is how you can find. So if you make it suspend from two different positions, you'll get two lines. So center of mass must lie on both the lines. So the intersection is the center of mass. Clear with this? Next thing. Any doubts so far? All clear with this? Tanishka? Trishi? Clear? Sudiksha? Ishman? Anvita? Aditi? Devanchi? Ovia? Perfect. Then this is another important one. You must have heard this in school, center of gravity. Why vertical? God, why are you not listening? I was telling you torque will be 0 or else it will rotate. For now, let it be. I'll show you in rotation anyways. Because if it is not exactly the vertical, then the mg is vertical, na? The gravity should pass through that. Weight is always vertical, so that way. So you must have heard this in school, center of gravity. Technically speaking, center of gravity is more powerful than center of mass. So what is the difference? Center of gravity is a point about which the net force acts. If the gravity is uniform, matlab if gravity is not changing, everywhere it is the same gravity, the center of mass and center of gravity will be same. Now, for most of our cases, we assume the gravity is almost constant on the Earth's surface, so both are almost will work out. If gravity is uniform, then center of mass, and I'll call this thing COG, are same. So just to give an idea, if you take a very tall building, or it's a tall rod, so the building is so tall, we are assuming gravity is actually changing. You will notice the lower floors will experience more gravity, and the higher floors will experience less gravity. That means overall, the lower part of the building experiences more force, so this will be the center of gravity. Whereas the center of mass, because the whole thing is symmetrical, the center of mass will be in the center. So if the gravity is changing, then both will not coincide. But for all practical purposes, we can assume they have to be same. Gravity does not change that much. So here, lower floors experience more force. Technically, we don't have this in the portion. But they can frame questions on this in gravitational chapter. We will see there. So use center of gravity when small g changes, the acceleration due to gravity. The formula for this thing is the position vector of center of gravity is integral RdF by integral dF. We will study this in gravitation. For now, just have an idea. If you make F is equal to mg, you will get the same formula. Gg will cancel, you get integral Rdm by dm. Yeah, but technically center of gravity is more powerful. It's a much better one than center of mass. Center of mass will work only when gravity is constant. Center of gravity works anytime. There, these are all the properties of center of mass. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how they'll frame questions, maybe theoretical ones on everything. So it is pretty easy to find center of mass of particles. Just use the formula M1, R1, M2, R2, and you're done. Next thing, continuous bodies. That is where we are more interested on. Let's see, for today we will just deal with the rods and all. Next class we will do more important shapes. So let me show you 1 or 2 examples and then we'll go ahead. Any doubt so far? Center of mass of continuous bodies. The first shape that we deal is uniform rods. I have shown you a few things like this in calculus, but here we are going to use it extensively. Now see one thing, right? Luckily in physics, right, we have only few standard shapes. So whenever you see a shape, if you know how to choose an element, half of your problems will be solved. So whenever you take a rod, here I'm taking a uniform rod, but whenever you see a rod, remember the elements are small rods. I'll tell you what it means. Before jumping into this, we have few terminologies. We use symbol called lambda. This is called linear mass density. I taught you this in NLM if you remember. This is mass per unit length. We generally use this for rods and arcs. We use something called sigma, which is surface density. This is mass per unit area. We use this thing for sheets. Like triangle, square plate, rectangle, all that stuff. Rho is your volume density. This is what you studied in school, mass per unit volume. So let me show you one question, like, easy one, uniform rod. Let's see how to take the elements, and then I'll give you more. So we got a uniform rod. You can see and tell the answer. Center mass will be in the center, but let's see. X is equal to 0, X is equal to 12. Okay. First thing. Now see, if everything was a particle, I know what to do. But here, it's a continuous rod. So at a distance x, take a small slice dx. So for this small piece, the coordinates are x comma 0. Since dx is so small, I can treat it like a particle, right? Whose mass will be dm, which is lambda into dx. Lambda is what? Mass per unit length. So mass per unit length into length of that small piece will give you the mass of that small dx. So dm is the mass of the dx length. If it is a uniform rod, lambda also will be capital M by L. Are you getting how I wrote lambda dx? Lambda is mass per unit length. If you multiply that with the length of the rod, you will get the mass of the rod. Then the formula for center of mass, x center of mass will be integral x dm by integral dm. Integral, so x is the x coordinate of the dm, which is x. Dm is lambda dx by integral lambda dx. What are the limits? Understand the meaning of limits. You took this piece at distance x. So when you put x is equal to 0, the piece is here. X is equal to L by 4, the piece is here. L by 2, 3L by 4, and so on. That means when you take from 0 to L, I'll cover all the pieces. So the limits will go from 0 to L. You need to understand the meaning of limits. You have taken a piece dx at a distance x. So the first piece starts where? At x is equal to 0. When does the last piece end? At x is equal to L. So the limits will go from 0 to L. Here lambda is constant, integral x dx. 0 to L by lambda integral dx 0 to L. Lambda cancels off. We get L square by 2 by L by 2. This is the process for finding center of mass for a rod. This is a uniform rod, so it is obvious it will be at the center, but this is the process. Have a look at this. Now let's do a question based on this. Clear with this? Let's see. We have a rod, x is equal to 0, x is equal to L, and let's say lambda is equal to lambda naught x square. Find the center of mass. Means look at the rod. When x is 0, there is no mass. As x is increasing, the mass is becoming heavier and heavier. So this rod will look like this. It is heavy, more mass, more mass, more mass, more mass. The rod is becoming heavier and heavier on the right hand side. Let's get this. Easy one. You just have to replace lambda with this and you're done. Hmm. Right, Samyak. Right, Shreyansh. Right, Vedika. Again, same story. At a distance x, take a small slice dx. dm will be lambda into dx. But what is lambda? Lambda naught x square dx. Therefore, x center of mass will be integral x dm by integral dm. This will be x into lambda naught x square dx from 0 to L. There, I mean, once you understood how to take the element, right, the integration will be quite easy there. L power 4 by L cubed by 3. 3L by 4. And again, I hope you understand the meaning of this. The meaning of this is, if you take this rod and throw it into the air, this point, which is 3L by 4 comma 0, this will go in a parabola. Everything else will go in circles. Getting the meaning of it? That is the meaning of center of mass there. So if you take this rod and throw in there, the center will not go in a parabola. 3L by 4 comma 0 will go in the parabola. Sure with this? So rods are pretty straightforward. You take lambda dx and substitute and you're done. Yeah, most of you got it. Others check why you didn't get it. Let's see one more. Let's say I have a shape like this. This is your x-axis, theta, theta. This is your y-axis. This is a rod of length 12. This is a rod of length. It's a uniform rod, but it is bent like this. Find the center mass of this. Give me the coordinates. A uniform rod is bent into an equal V shape. Find center of mass. I want both the x coordinate and y coordinate. So this tip here is your origin. X-axis is the angle bisector. Well, cos theta by 3, 3L. No, sure, yeah, that is wrong. Nee, Samyak, you goofed up. You are close by. You goofed up something. Check karo ek baar. Nee, Srihari. That is wrong. Try others. I'll give you a minute. Right, Siddhesh. Have one answer. No, sure, you're wrong. Srihari, that is also wrong. Get me the x coordinate, na? Y coordinate is right, I guess. Y is right. Get me the x coordinate. What is the point of just finding y? Give me both. Let me tell you, the most common mistake what people do here is this. If a rod of length L has mass m, then rod 2m will have how much mass? 2m, right? Both the pieces don't have same mass. That is one common mistake people do. If you have not done that, then it is good. So this is theta, this is theta. So for this rod, now again, I don't know the exact value, but it will be at the center. Are you getting it? 2m. So this length will be L. The center of mass will be at the center of the rod. So this coordinates will be L cos theta, comma L sin theta. This center of mass will be here, mass m, and this is L by 2. So this coordinates will be L by 2 cos theta minus L by 2 sin theta. This is what I was saying. That means you can replace this entire rod with one particle at the center. And then find the center of mass of those two particles and your job's done. So x center of mass will be, so the big rod ka mass is 2m and the x coordinate is L cos theta. This is m, L by 2 cos theta. By total mass, 3m. This is the advantage of that. If I give you some weird shapes, this is what you can do. You can split it into the shapes which you know. I know the rod ka center of mass is at the center. Put the mass there, get the coordinates and finish it off. How much is this? This is 2 plus 1, 5. 5L by 6 cos theta. Similarly, if you look at the y center of mass, it will be 2ml sin theta minus ml by 2 sin theta by 3m. That would be L by 2 sin theta. Check. Yeah. Masses won't be same. Just be careful with that. You just have to replace that rod with a particle at the center, and then it becomes a particle problem. Easy. Let's see one more like this. Any doubts on this? Let's say we got a 90-degree wall. We have a caterpillar. Okay. And this caterpillar is going with a constant speed u. Mass of the caterpillar is m, length of the caterpillar is L. We can treat it like an uniform rod. It's a uniform caterpillar. Basically, assume it to be a uniform rod, but it is moving. But technically, whenever a caterpillar moves, what will happen? Some parts become fat and some parts become thin. So it's like a variable rod. Let's not get into that. Let's assume it is a uniform thing. Let's keep our life simple. Assume it is a uniform rod. Okay, this is the scenario at t is equal to 0. Now, as this caterpillar starts going, it starts climbing the wall. It's still going with a constant speed u. This is the scenario at time t. So at some time t, some part of the caterpillar is on the wall and some part is on the floor. Find, take this corner as origin That's your x and y axis. Find position vector of center of mass. Find velocity of center of mass. Find acceleration of center of mass at time t. If your center of mass is moving, then you'll have velocity and acceleration also. This is for the time t less than L by u. Means I don't want the caterpillar to completely climb the wall. So I want the position vector, velocity and acceleration when the caterpillar, some part is on the wall and some part is on the floor. For t greater than L by u, the caterpillar will completely climb the wall. It just goes straight on a y-axis. So we are talking about an intermediate stage. I hope the picture is clear. Must have seen caterpillar multiple times doing this. Let's find the center mass of the caterpillar at time t. Let's see how you handle this. No, Samyak, I'm missing out on something. You got there, but you messed up. You missed something. Think for 30, 40 seconds, then I'll tell you what you're missing out. Nee, Srihari. Did you get it, Samyak? Do you think the mass of the caterpillar on the wall and the floor is same? Even that is changing, na? Did you take that into account? You didn't take that. तो दोनों को हम ले लिया. The mass on the floor and the mass on the wall is changing with time. Understood? Let's see. Others, everyone should try. I'll give you a hint, Sane. Let's draw the picture like this. So you can treat this thing as two rods, okay? You can treat this is one rod, and you can treat this as one rod, the caterpillar. So after time t, this will travel ut distance. So the length of the caterpillar on the y-axis is ut. That means this length is L minus ut. So for this vertical part, this is the center of mass. For the horizontal part, this is the center of mass. Agreed? So I want you to find the center of mass of these 2 points, isn't it? So you can just treat the caterpillar as two rods at an L shape. So the vertical rod is ut length, speed into time, and the remaining length is L minus ut. If I take this mass to be m1 and this mass to be m2, mass also will keep changing. So what is mass m1? Total mass of the rod by total length of the rod into L minus ut. This is m1. m2 will be total mass of the rod by total length of the rod into ut. This is m2. And what is C1 ka coordinates? C1 ka coordinates will be L minus ut by 2, comma 0. This coordinates will be 0, comma ut by 2. There, you know the masses, you know the coordinates. Then your x center of mass will be m1 L minus ut by 2. The other one is 0 by total mass m. Y will be m2 ut by 2 by total mass m. Substitute here, this would be L minus ut whole square by 12. That's your x center of mass. Y center of mass will be u square 2 square by 12. Therefore, the position vector of the center of mass will be L minus ut whole square by 12 plus I cap plus u square t square 2L j cap. There, that is how you do this. Okay. The squares will come. Right, Aditi. Near Anvita, that is L minus ut ka whole square, na? Right? Now, what do you want to find? Velocity? How do you find velocity? Differentiate dr by dt. If you differentiate this chain rule, the 2 will cancel off. You will end up with L minus ut, and with one more extra minus u will come by L I cap. This will be u square t by L j cap. That's your velocity. 2 into L minus u2, 2 will cancel, then differentiate whatever is inside. You want accretion center of mass? Differentiate again. This would be minus u square by L I cap plus u square by L j cap. That once you got the center of mass, it's just a matter of differentiating. Minus of minus plus आएगा ये. Yep. Clear with this. Just keep differentiating this. So the main thing is to realize even the mass is changing on the floor and the wall. Any doubts on this? Let's see one more. Let's see one more. Let's say you made a rod. This is your x is equal to 0. This is x is equal to L1 and this is x is equal to minus L2. The right side of the rod is made of a different density, which is lambda is equal to lambda naught x. The left side of the rod is made with something else, where it is lambda 2 is equal to lambda naught x square. Both the sides, the density is different. You're getting? So you took two different rods and you just welded them at the center at x is equal to 0. And we observe, interestingly, the center of mass is at x is equal to 0 only. So find relation between L1 and L2 if the center of mass is at x is equal to 0. So these two rods ka center of mass is at x is equal to 0. Let's get this. You have taken two non-uniform rods and you welded them. And it is observed the center of mass of the two rods is at the center. Here the dimensions won't match because this is lambda naught x square. I took lambda naught x, so don't worry about the dimensions part here. I should have taken it as lambda naught x square by L2 square and lambda naught x by L1, but it's fine. Okay. Let's not worry about it. L1 cube root 4 by 3 into L2. L1 is cube root of 4 by 3. Nere Shaurya. Ne Shreyansh. Right, Samyak. You have one answer. Try, I'll give a minute more. I'll give an idea here. First of all, just let's find the centromers for each one. The left one we already found out. So the left rod, the x centromers will be integral x dm, which is lambda naught x square dx by integral lambda naught x square dx 0 to L2, 0 to L2. This will be 3L2 by 4. This is the problem which we did. Lambda naught x square, 3L by 4. For the right one, the x centromers will be again x into lambda naught x dx 0 to L1 by integral lambda naught x dx 0 to L1. This will be 2L by 3. Similarly, let's find the mass also. M1 will be integral dm, which is integral lambda naught x dx 0 to L1. This is lambda naught L1 square by 2. That is the mass of the right side rod. This mass is let's call M2, which is integral dm. What is dm? Density lambda naught x square into dx. 0 to L2. This is lambda naught L2 cube by 3. So if you look at this data here, I know the mass of each rod and I know the centromers of each rod. Making sense? Now what I will do, so this is x is equal to 0. So basically I can replace that entire left side rod with a mass M2 at minus 3L2 by 4 comma 0. and I can replace the entire right side rod with M1 at 2L1 by 3, 0. Do you guys agree with this? You're replacing that entire rod with a mass M1 and M2 with center of masses. And now you're telling me these two particles' ka center of mass is at the origin. So X center of mass is M1, 2L1 by 3 plus M2 minus 3L2 by 4 by total mass M1 plus M2 is 0. M1 is how much? Lambda naught L2 cube by 3, 2L1 by, this is M1 is this lambda naught L1 square, 2L1 by 3 minus M2 is lambda naught L2 cube by 3 minus 3L2 by 4 is equal to 0. 2 will cancel. Lambda naught also will cancel. L1 cube by 3, L2 power 4 by 4. Check. So if this condition is satisfied, then the center of mass will be at X is equal to 0. See where it went wrong. Right, Utsa? Right. Right, Shaurya. It just, the way you typed it, it was confusing. I didn't understand. But again, it was same. All clear with the steps what I did? I just found the mass of the rod. I found the center mass of the rod. I just replaced them with two particles. And the center mass of the two particles at X is equal to 0. This is what I was saying. If I give you a system where it is made of different pieces, then find the center mass of each piece, replace them with particles, and then solve the problem. All clear with this? There, that is how you handle rods. The rods is straightforward. So next class when we catch up, we'll continue from here. We're going to see other shapes. We're going to see arcs and we're going to see spheres and all that stuff. Next class will be important for integration. I would suggest you please go through once the calculus ka notes. That would help, especially this part. Areas and volumes. Page 114. I taught you how to take elements, rings and all. Just have a look at this and come. All this stuff, we are going to do all this stuff will come again, but we're going to do it at a different level. So next class when we catch up, we'll continue from here. And like I said, next class will be important. It will be the foundation, it will be the first time you'll be seeing proper applications of that calculus in choosing elements and stuff. And that will form the basis for the chapters going ahead. So, okay, with that, we'll wrap up for the day. So I'll see you guys again next week. We'll continue from here. So any doubts, anything else, please stay back and ask, or else you're free to leave. So take care, stay safe.